So let's keep going to keep on time. The next speaker we have is Merete from Norway. Merete, are you ready?
Yes.
Wonderful. So Merete, you have 5 minutes.
So, good morning. I'm going to tell you about the Norwegian smelter cohorts, which I'm currently working with. Norway is, as you may know, a country with high mountains and deep fjords, and a lot of water falling down from the mountains. From the end of the 19th century, the development of hydropower in Norway gave almost unlimited amounts of cheap energy and great possibilities to develop industry with high energy demands, such as, for example, metal smelter industry. From the beginning, the smelter industry plants were located close to the power source, deep into fjords and often at very remote places, where small villages grew up around the plant. Later, when electricity became easier to transport, the possibility for a safe and deep harbor was more important for the localization of industry. But where the plants came, they regularly became the cornerstone of a quite wealthy little society, and were thus appreciated, even though they were hideous, and the smoke from the factory could be quite bothersome. Ferroalloys are various alloys of iron in combination with other metals, giving the cast iron and steel distinctive qualities. Production of ferroalloys demands temperatures of over 1000 centigrades. Starting around 1900, the production of ferroalloys in Norway was for many decades among the largest in Western Europe. In the 1980s and the early 1990s, an historical industrial cohort was established with the data from several of the ferroalloy plants, including the production of ferrosilicon, silicon metal, ferromanganese, and silicomanganese alloys. Around 16,000 employees were included, and the cohort contained personal identification of the subjects and information about up to 10 different employment periods per person in different departments and jobs at the plants. Due to the Norwegian personal identification number, the cohort could be linked to the Norwegian Cancer Register and the Cause of Death Register. And Ånund Hobbesland wrote his doctorate on cancer incidence and mortality in this cohort around 2000. Silicon carbide is formed by fusion of silicon in quartz and carbon in coke via a gas phase reaction at about 1700 centigrades. Carbon monoxide is a byproduct of the reaction and has to be burned off the furnaces immediately in order not to poison the workers. The end product is beautiful, a mass of brittle crystals, almost as hard as diamond. In addition to its primary use as an abrasive, its diverse properties have allowed for the development of many other uses, such as ceramic materials, diesel particle filters, and wire saws for cutting solar cell panels. 3 plants in Norway have been producing silicon carbide, the first starting in 1913. The silicon carbide worker cohort was assembled in the 1990s by Paul Romenstad with about 2,600 male participants, and he wrote 2 papers on cancer and mortality in the cohort in the early 2000s. He observed increased lung cancer incidence and increased mortality from non-malignant respiratory diseases, and this gave the basis for Solveig Føreland's PhD on developing a job exposure matrix for the industry, and my PhD on a cancer and mortality update using this gem. So to the present, there is quite clear evidence that increased urban pollution and probably mainly exposure to fine and ultrafine diesel exhaust particles increase cardiovascular morbidity and mortality among the inhabitants. Our present research interest is the effects of exposure to ultrafine particles, that is, particles less than 100 nanometers in diameter, which is formed in the heated environment in the furnace halls of ferroalloy smelters and silicon carbide plants. Do the workers in furnace halls have a greater risk of cardiovascular mortality than other blue-collar workers not exposed to the ultrafine particles? So we have merged the ferroalloy and sick cohorts, giving an old cohort where actually more than half of the subjects have died, and a new linkage to the cause of death register have been performed, updating until 2014. So our primary interest then is contrasts in cardiovascular mortality between furnace workers and other blue-collar workers. Unfortunately, there is a good balance between the two groups, and hopefully the paper will be published next year. So thank you for your attention.
Okay, thank you very much, Merete. It's nice to see the diversity of cohorts represented in the meeting here. Are there any questions for Merete? I suppose the cohort is quite unique.
Yes, I would believe if anyone has a cohort that we can merge with, it would be very interesting.
Good. Yeah, so please get in touch with Merete if anyone would like to discuss that with her. So I don't see any questions, so let's keep going to stay on time. Thank you very much, Merete.